I hope you enjoyed the premiere of the Red Reader yesterday. Predictably, maybe I would just start jamming on guitar right now. But my hands need to rest. My brain needs to rest. And there's a lot to process. The Red Reader, all the sounds I can get on my fingers now. So rather than just start off jamming in videos like that, which believe me, I thought I would take a step back and do the unpredicted thing, and do a quick tour of the calculus, and it's a type of math, and also correct a mistake I made, a slight one, but still one, that I made yesterday when I was talking about pi and circles and spheres and stuff. So if you bear with me, let's just do a math video, and we'll get to lots of shredding soon. But let's do this first. Why not? So first of all, hope you can see the board good. Well, the circumference of a circle is pi times the diameter. By definition, that's the definition of pi. Which, since the diameter is twice the radius, then that means the circumference equals 2 pi r. So that's very. A lot of people know that, and that would be the truth. Now, a funny thing is that to find the area of a circle, that brings it up to the second dimension, from r to r squared, and it turns out that you use the integral of the circumference to find the area. I'm going to go into integrals in a minute because integrals are a calculus thing. But rather than do the calculus right away, the circumference equals 2 pi r. Now in calculus, if you want to find the integral of a polynomial or a monomial, in this case is a monomial, to find the integral of this, you raise the r to one more power and then divide by that. So the integral, written like this, it's kind of like an S, like a summation thing, of c equals 2 pi r squared divided by 2. That's just the, if you can Google that. What is the integral of a monomial? You take the variable, raise it the power by 1, divide by that. And since that 2 divided by 2 is 1, that the integral of the circumference is the area equals pi r squared. And that's a quick way of understanding a little bit of why that's the area, rather than just memorize it. You know that if the circumference is 2 pi r and area is the antiderivative or integral of the circumference, then that means the area is pi r squared. And that, so far, so good. So far, that's what I said yesterday. But then I made a slight mistake I want to correct right now. I made a slight mistake that is important, though, because mistakes are as important as what you're trying to say, because you're saying something wrong. Now, with spheres, now we're talking about spheres now. This is three-dimensional things. The surface area of a sphere is 4 pi r squared. I'm not really sure why that is, but what it happens is that if you take 4 surface areas of a circle, if you take one, if you start with a surface area, the area of a circle, and you want to cover the sphere, the surface of a sphere with that much area, it takes 4 of them to cover the whole sphere. That just is. I'm not sure why, but if I have a flat surface area, it takes 4 of those to make the surface area. I should say area of a circle. It takes 4 of those to make the surface area of a sphere of the same radius. But here's where I made a slight mistake yesterday. I want to correct. Therefore, the volume of a sphere is now the integral of this. Not what I said last time. I said it was the integral of the that wouldn't make any sense. I said it was the area. I said it was the integral of the area of a circle. That would make no sense right now. So this is what I start with. The surface area of a sphere is 4 pi r squared. To find the volume of the sphere, I'm going to up it to one more power. It's going to go from second dimension to third dimension because volume is third dimensional. And I use the same formula. I make the integral of this monomial. What do? Start out with the same. You raise the power by 1, divide by that. So I start with 4 pi. I'm going to raise the variable of r from 2 to 3. So r3, then divide by that. And that's the truth. The volume of a sphere is 4/3 pi r cubed. It comes from integrating the surface area of the sphere, which is 4 times the area of the circle, not integrating the area of the circle, like I said haphazardly yesterday. So that's a little bit of geometry, but I relate it to calculus. Nobody told me about the integration thing. I figured that out on my own, but it makes sense if you understand, calculus and apply it to geometry. That's the way I look at that. Rather than just memorizing the formula, I want to know where it came from and how to get it. So now just a little bit of calculus, and then I'll probably won't do math for a while on this channel. Anyway, what should I say? Calculus is like if you have a function and you want to know like what's the rate of change of the function at any given time, and that would be the instantaneous slope, and that slope is called the function of the slope is called the function that is the slope of this line at any given point is called the derivative of that line. The derivative is the rate of change of the function at any given time, and that itself is a function called the derivative. And it turns out, like I said before, let's say a polynomial. If f of x equals x squared plus x plus 1, then the derivative f prime of x is not the opposite of what I did with the integral. To find the derivative, you take this number times let's make it a little more interesting. Let's make it 2. Let's do that. Okay. What you do is you take this number, the exponent of the variable, times this, and then subtract this by 1. So now to get the first derivative, 2 times 2 is 4, and then take the 2 down minus 1, you get x. 2 times 2, 4, and 2 minus 1 is 1, so 4x. In this case, this is x to the 1. 3 times 1 is 3, so you would say plus 3, but lowering the power from 1 to 0 makes that 1, so you just have 4x plus 3. And then here, you just have, this is x to the 0, because x to the 0 is 1, and when you multiply 0 by that, you get 0, so that doesn't come out to anything. So the derivative of 2x squared plus 3x plus 1 is 4x plus 3. And that means that at any given point, x, this function, the slope of this function, the rate of change of this function is this function. So that would mean that, let's say x equals 2. At f of x, if f of 2, if f of x is 2x squared plus 3x plus 1, then f prime of 2 is just 11. That means at the point x equals 2, this function right here is changing, or the slope of it is 11. That means that for every 1 x moving forward, there's 11 x's going upward, because the slope is the y over x, the rise over run, the height of the motion divided by the length of the motion. So that's a pretty high slope like this. It means it's going up like that. 11 over 1 would be the slope at the point x equals 2 of this function f of x equals 2x squared plus 3x plus 1. So that's a little bit of calculus there. If I don't say all this, I'm going to think I didn't say it and then want to say it later. So let's just get it all out of me, kind of thing. You know what I'm saying? I hope you can see the board all right. Now there's a thing called the antiderivative or the integral, which I've already alluded to, but not diluted, alluded. Here's a function like this. Now this time I want to take the integral of this function, And that's the antiderivative. That means what function, if you take the derivative of it, would equal this function? Well, the area under the curve is changing each time you move up. From the area of the curve is changing at the rate of the function itself. So if you call this f of x and you call this function g of x, then g of x the rate of change of g of x is equal to f of x. That means g prime of x equals f of x, because the slope changes as you go from here to here at the rate of this function itself, because every time you add another little bit, this function f of x gets added to the area, this function in the area. It's like each time you add something to g of x, what you're adding is whatever f of x is. Therefore, the rate of the derivative of g of x is f of x. But if you integrate both sides, that would mean that the integral of the derivative is the same function. So integrate both sides. Integral of g prime of x is g of x, because that's the integral is the opposite function, the opposite operation of differentiation. The integral of f of x is just the integral of f of x. So that means that the integral of f of x is g of x, the area of the area of under the curve. So that means that the integral of f of x is g of x, where g of x is the area under the curve, and that's a brief introduction to differential and integral calculus. If this goes over your head, that's too well. You'll eventually it'll sink in later. If you get it, then that's cool. We agreed on something. If you didn't know it and you understand it, then I taught you something. That's cool too. One more thing, the chain rule. I gotta get all this stuff out of me, or I'm gonna say I didn't do that. The chain rule is a derivative of a function within a function. So if I have g of x. That's not there. Let's say I have g of x equals f of g of x, like that. Not at g. G of x equals f of h of x. How about that? The function of a function, and that function itself is a function. The derivative of g of x equals the integral of f. The derivative. The derivative of g of x equals the. I'm going to write down here the derivative of f of h of x times the derivative of h of x. So that's called the chain rule. If you have the function, your first function is a function of a function. The derivative of the first function is the derivative of the first function of the function times the derivative of the function that is within the function. You kind of see that kind of? So I'm going to give you that by example rather than just what is he talking about. So let's say I have g of x equals, let's say 3x to the 2x plus 1, like that. So this is a function of a function, and this is a function. So the derivative of g of x is now, I treat this as a thing first. So this times this is 3 times 2x plus 1 times this minus 1, which is, so I'd write 3 times 2x plus 1 times this minus, and this goes down to 1 by 1, so x to the 2x. And that's a 3 there. But then I got to take this times the derivative of this thing, which is 2. So that would mean this all times 2. So the derivative of this is 2. So now I have 3 times 2x plus 1 to x to the 2x times 2. This becomes 6x plus 3 times x to the 2x times 2. Put that right here. And this doesn't make any sense. Well, it's on video for anyone to see later when you do think you want to try to get it, and then you can look at it later. It's not like it goes away. 2 times 6, this thing is 12x plus 6 times x to the 2x. X to the 2x. So that, and then you could simplify. You could also do that. You could continue that as 12 x to the 2x plus 1 plus 6x to the 2x. That's simple math. Because this times that, you take 12x, 2x plus 1 plus 6x. So that thing right there, that is the derivative of my original function, which if I can remember right, if I can even remember the function I started with, I said g of x was something. I thought it was, what did I say? I wasn't paying much attention, but that original function I wrote as g of x by the chain rule is this thing. And I don't remember what function did I just write. X, what did I say? Did I say 3x to the 2x plus 1 times x? No. Oh, yeah, was it something like that? Yeah, that was it. 3x to the 2x plus 1. So if g of x equals 3x to the 2x plus 1, then g prime of x, or the derivative of g of x would be that. Let's make sure that's true. You take this times this, that'd be 6x plus 3. All right, and then this is 2x, and then times this is, oh, wait, okay. That makes sense. Oh, wait. Oh, the derivative of that. Oh, no, that's not what I did. I don't remember what my original function was, but whatever I wrote as that should be what it is. Just in case that went, oof, let's try another example. It's the same idea, but let's just try a different example. That way, you can hear it done, see it done twice rather than just once, and you get it or you don't. This time, g of x equals 4x to the 3x squared plus x. Try something a little harder. That's g of x. Now, the derivative of g of x, g prime of x, is this times this minus 1. So that would be equal to 4 times 3x squared plus x. It's that first. Times, I'm going to put that 4 better. I can't write very well. There's that, 4x squared plus x. And then, yeah, and then times x, this minus 1 would be x to the 3x squared plus x minus 1. Yeah, because the derivative, you subtract 1 from that. X plus 1. And this is 4, there's that, times the derivative of this. So that would be this, that would be 6x. God, if I could just write, dude. 6x plus 1. That's the derivative of 3x squared plus x. 6x plus 1. So that gets multiplied by all that. See that? And that would mean that this thing times x to this is the answer. So it's some complicated. That would be 12x squared plus 4x times this. There's that. So that would mean times 6x plus 1. That would, and then that, all that times x to the 3x squared plus x minus 1. See that? Then you just multiply that polynomial out. I'm really not going to remember which function I started with this time, because this is even harder than the last one. So I have 12x squared plus 4x times 6x plus 1 times x to the 3x squared plus x minus 1. So the FOIL rule, first, out, last, inner, outer. First is 72 x cubed. There we go. Plus, and then the last is plus 4x. Inner is 24x squared. Outer is 12x squared. So I have this whole polynomial times x to the 3x squared plus x minus 1. And that would be the derivative of that original function. I can simplify that a little. X cubed, I could say, let's see, could I simplify that a little? Sure, I could. 24x squared and 12x squared is 36x squared. So no need to have those as separate things. So then I would go, I'm getting my math back, so pardon my whatever I'm doing. 72x cubed plus 36x squared plus 4x, all that times x to the 3x squared plus x minus 1. There is the derivative of that original function that was a function of which was a function of a function. And that looks, yeah, I think that's right. It looks right to me. Yeah, that's about right. So anyway, this is has been a tour of the calculus, very simple terms. They say in picking on guitar, what separates the men from the boys, sort of, or the girls from the women, is can you pick at mid-tempo? Can you pick consistently alternate picking, not just slow and not just fast, but mid-tempo? Well, to me, calculus is mid-level math. It separates the men from the boys or girls from the women in math, because a lot, if you're just pre-calculus, you're only at a certain level. But if you understand calculus, that's the gateway to higher math. All higher math uses and at least uses, if not is based on calculus. If you understand calculus, higher math that's like the gateway drug to higher math is calculus. If you get your head around calculus, higher math shouldn't be much of a problem to you. But if you can't get calculus, higher math won't be available to you, most likely. Love you guys. Peace, love, and rock and roll.